Hello everyone, welcome back to class. This is our second lecture of class 7th, chapter 1, integers. In last video we have discussed properties of integer under operation addition. Today we are going to discuss property of integer under operation subtraction. In under addition, what property we have discussed? Closure property, commutative property, associative property, and additive identity. These four property already we have discussed. Now similar property we are going to discuss under operation subtraction. So let us see what is first property. First property is closure property. First property is closure property. What is closure property? Closure property under subtraction. Under operation subtraction we are going to do closure property under subtraction. So what is closure property? A minus B. A and B are two integers. If I will subtract these two integers, then these must belongs to integer. You will write let A and B belongs to integer, then A minus B must belongs to integer. If it belongs to integer, then we can say subtraction is closed. Subtraction is closed. Let us do this property by taking particular example. Let A is minus 2 and B is 5. A is minus 2 and B is 5. Then A minus B will be minus 2 minus 5. Answer is minus 7. Minus 7 belongs to Z. Minus 7 is further an integer. So subtraction is closed in case of integer. Subtraction is closed, or closure property is satisfied under operation subtraction. You can take another example of A, B and C. A value is minus 15 you can take, B value is minus 5 you can take. So A minus B, minus 15 minus 5. That is minus 15 minus plus 5. Answer is minus 10. Minus 10 further is an integer. So subtraction is closed. This is first property under operation subtraction, that and we get subtraction is closed. Next property is commutative property. What is next property? Next property is commutative property. What is commutative property? Under operation addition we have studied it. A plus B must be equals to B plus A, where A, B are integers. So if this condition is satisfied, then we were saying integers are commutative or addition is commutative for integers. Now we are going to check this commutative property under operation subtraction. If this condition will be true, A minus B is equals to B minus A, then what I will say, I will use that subtraction is commutative. Subtraction is commutative for integers. Let us take, let A and B belongs to Z. Z means integers. Then if A minus B equals to B minus A, then we can say subtraction is commutative. Let us do verify this property by taking particular value of AB. Let A is minus 2, B equals to 3. So A minus B, minus 2, this is A minus B. Value of A is minus 2, B value is 3. Answer is minus 5. What is answer? Minus 5. B minus A. B minus A. What is B value? B value is 3. A value is minus 2. Answer is 3 minus plus 2. Answer is 5. Answer is 5. So A minus B is minus 5 and B minus A is 5. As A minus B is not equals to B minus A. A minus B is not equals to B minus A. So we can say that this subtraction is not commutative. Subtraction is not commutative. Subtraction is not commutative. So this property also we have studied. What is commutative property? A minus B and B minus A. If this condition is satisfied, then we can say subtraction is commutative, otherwise no. So A minus B is not equals to B minus A. Subtraction is not commutative. By taking particular value of A and B, we verified that subtraction is not commutative. Next is distributive property. What is distributive property? Like, what was distributive property under operation addition? It was A into B plus, I will write it A into B plus A into C. This was under addition. Now we can say this multiplication is distribute over addition. Multiplication is distribute over addition. Let us check A into B minus C. A into B minus C. So it must be like this: A into B minus A into C. A into B minus A into C. Let us check out this property by taking particular value of A, B and C. Let A equals to 2, B equals to minus 2 and C equals to 1. You can choose any other different value, but this A, B, C must belongs to integer. A, B and C, these belongs to set of integers. Now let us calculate A into B minus C. Value of A is 2 and value of B is minus 2 and C value is 1. So its answer is 2 into, first solve this bracket, minus 2 minus 1 minus 3, multiply, it is minus 6. Now A into B minus A into C. A into B minus A into C. This right hand side we are going to solve. What is value of A? A is 2, B value is minus 2, A value is 2 and C value is 1. This is minus 4 minus 2. Answer is minus 6. As we observed, A into B minus C is equals to A into B minus A into C. A into B minus A into C. So we can say this multiplication is distribute over subtraction. Multiplication is distribute over subtraction. Multiplication is distribute over subtraction, and there also multiplication is distribute over addition. So this was distributive property. Next is associative property. Associative property under operation addition, I have shown you what was A plus B plus C is equals to A plus B plus C. How we will read it? A plus B plus C equals to A plus B plus C. In this way you will read it. So this was verified. This was associative property of integer. Now we are going to check it under operation subtraction. So according to this property, for subtraction it must be like this: A minus B minus C, then must be equals to, if condition I will write and I will verify by taking particular value of this A, B and C. If this condition is satisfied, then I will say this associativity properties hold in integer under operation subtraction, otherwise no. This must be opened in this way: A minus B, then multiplication of this A with the A minus B. Okay, first A minus B and then minus C, in this way. If this condition is satisfied, then we will say This associative property is verified under operation subtraction in case of integer. How you will read it? A minus B minus C, then A minus B and then minus C. First you will calculate B minus C answer and then you are going to subtract it from A. And there what is condition? A minus B, you will find out this one answer A minus B and then from this you will subtract C. Let us do this by taking particular value of A, B and C. Let A equals to minus 2, B equals to 5 and C is equals to 10. A equals to minus 2, B equals to 5 and C is equals to 10. So A minus B. A minus B minus C. What is A? A is minus 2. What is B? B is 5. And what is C? C is 10. So it is minus 2 minus this 5 minus 10, answer is minus 5. So this is minus 2 minus minus plus. So answer is 3. Answer is 3. Now A minus B and minus C. What is A? A is minus 2, B is 5, minus C minus 10. Minus 2 minus 5, answer is minus 7 and minus 10. So answer is minus 17. Clearly we can say A minus B minus C is not equals to A minus B minus C. So this associative property doesn't hold in case of integer under operation subtraction. So this was associative property under operation addition and subtraction. So now some property of multiplication I want to discuss. Properties of multiplication, like what is multiplicative identity, multiplicative inverses, like additive identity is there. So we are having multiplicative identities also. Multiplicative identity. What is multiplicative identity, or we can say what is additive identity of integer? If I will ask, you will say A plus 0 is equals to A, minus 2 plus 0 is equals to minus 2, minus 15 plus 0 is equals to minus 15, 25 plus 0 is equals to 25. So this 0 is that number, if we are adding to an integer, then again we are getting same integer. Again we are getting same integer. So this 0 was additive identity for integer. Now what is multiplicative identity? If it is multiplication, then it is understandable that in place of this plus multiplication sign I will use. But what is there in place of 0 if I will multiply any integer and then same integer I will get? That is 1. Minus 2 into 1. Answer is minus 2. Minus 5 into 1. Answer is minus 5. 15 into 1 is 15. 100 into is 100. So this 1 is that number. If we are multiplying any integer, then again we are getting same integer. So we can say 1 is multiplicative identity of integers. 1 is multiplicative identity of integers. Now, what is multiplicative inverse? If multiplicative inverse, suppose of minus 2, this will be 1 upon minus 2. If we are multiplying, reciprocal we have to take. Multiplicative inverse of minus 2 is 1 upon minus 2. And additive inverse, additive inverse of minus 2 will be plus 2. Multiplicative inverse of minus 2 will be 1 upon minus 2 and additive inverse of minus 2 will be 2. If You will add number and its inverse, then you will get additive identity. This is number and this is its inverse, then you will get additive identity. Number, its inverse, and you will get identity. Similarly, for multiplication, if you will multiply number with its reciprocal or with its inverse, then again you will get multiplicative identity. Multiplicative identity. Minus 2 to minus 2 will be cancelled and answer is 1. So what is multiplicative identity? 1 is multiplicative identity of integer and 0 is additive identity of integers. 0 is additive identity of integers and 1 is multiplicative identity of integers. Multiplicative inverse of any number, how you will find out? Of an integer, if particular we are talking about integer, then you have to take its reciprocal. And additive identity of minus 2 will be plus 2. Plus number will be minus. Suppose 5 is there, then its inverse will be minus 5. So additive inverse of 5 is minus 5. Further, if we are adding number and its inverse, then we are getting additive identity. We are multiplying number and its inverse, then we are getting multiplicative identity. Okay. Now say some properties under division. Although how we can divide integers, how two integers, how we can divide, like minus 1 divided by minus 1. This minus to minus will be cancelled. Answer is 1. So some sign conventions are there. This minus plus. See, if we are adding 0 to any number, then we are getting same. If we are multiplying this 0 with any number, then answer will be 0. Now, if we are dividing this 0 with any number, then answer is 0. But if something over 0, then it is not defined. Not defined. That is 5 by 0, 9 by 0, any number by over 0. So this condition is not defined. Keep in mind, you can't write 0 in denominator of any integers. So just this point you have to keep in mind. Like we are dividing one positive integer and one negative integer. Let us do by taking example 5 by minus 2. Answer is minus 5 by 2. So we are getting our answer negative. What we are getting our answer? Negative. So this plus divided by minus, answer is minus. Or minus divided by this plus, again answer is minus. Minus divided by minus, answer is plus. And plus divided by plus, further answer is plus. And if in case of multiplication, minus multiply minus, answer is plus. Minus multiply with plus, answer is minus. And this plus multiplied with minus, answer is minus. Plus multiplied with plus, answer is plus. Product of two negative integer is positive. Product of one negative other positive integer will be negative, and product of two positive integer will be positive. Division of one positive, one negative integer will give us negative integer, and product of two negative integer will give us plus, means positive answer, positive integer, and division of two positive number again is a positive integer. Division of positive integer by negative integer, negative integer, we will get positive integer, and division of positive and positive integer, we will get positive answer. So tomorrow we are going to discuss its example and exercise. So till then you can revise this introduction. Thank you for watching.